have a quiz coming up on Tuesday. And so normally in class, we would have warm-ups each day of this week, and you would only have a couple of these per day. But because we are not in class, we are distance learning, you're getting these all at once today. There's 7 of them. One of these, number 5, we did for warm-ups on Friday. And so now you've had a chance to look at these and attempt each of these. Hopefully you did that. That's what a good student would do. And now let's go over them and look at any misconceptions that you might have and really feel confident and be ready for this quiz on Tuesday. There will also be a video going over the review. It'll be posted on Saturday today as well. Okay, because today when you're watching this should be Saturday, but right now it's Thursday when I'm recording this. All right, so it says, given the graph of f prime of x, sketch the possible graph of f of x. So when we're doing these, it helps when you have the a blank graph underneath the derivative graph so that you can kind of match up what's happening with the x values. Because we know the x values with this derivative graph. We know what x's are being used. What we don't know are the y's. So we're going to have to guess on the y's how far up and how far down we're going. So that's totally up to us since this is a possible graph of f of x. So I just wanted to emphasize that because sometimes we think it needs to be exact and we're like, how do we know where it goes or how far up or how far down? We don't. So we're guessing, okay? And that's totally okay. I'll show you what I'm going to be looking for when I grade these. All right, so on the graph of the derivative, remember these are all slopes. Derivatives are slopes. So when it's below the x-axis, these are negative slopes. When it's above the x-axis, these are positive slopes. So this is positive and this is positive, okay? Another thing is where it touches or crosses the x-axis at, because that means the slope is 0 when x is -2, and the slope is 0 when x is 1. So also, those slopes, these are our turns in the graph, okay? And a turn can be a minimum, like an upward-facing parabola, or it can be a maximum, like a downward-facing parabola, or we could have a shelf. Okay, that's where we could have horizontal tangents along a graph. All right, so how do we tell? Well, let's first start with the left-hand side. So we have at -2, there should be a horizontal tangent somewhere. So I could have it up here, down here. It doesn't really matter, okay? I'm going to put it down here. So since it's going from a negative slope to a positive slope as it crosses over the x-axis here, that means I know I'm going down, flattening out, and then back up. So I'll just make this keep going this way because it's decreasing on that side. And then there is my horizontal slope right here at -2, okay? So this ends up being a minimum value because the minimum of a parabola is the vertex of the upward-facing parabola. Okay, let's keep going. So as it crosses over and hits the x-axis at -2, that means the slope is 0. So right here, and then it's increasing. It's still got a positive slope. It's increasing, still increasing, but then it flattens out when it hits 1, and then it continues increasing. So that means at 1, I'm going to have increasing, flatten out, increasing. I'm going to have a shelf. Okay, so at this point, I'm just going to go, I need to show it's increasing, and then I want it to flatten out and make a shelf and then increase. Okay, so it's kind of up to you how you decide to make that happen. Okay, but we want the shelf to only be right there, and it is at an x value of 1. So when I grade these, this is what I'm going to look for. I'm going to look for the minimum at an x value of -2, and I'm going to look for the horizontal tangent, the shelf, at x equals 1. And I need to see that we're decreasing slopes, increasing, increasing. So I need to see that, okay? But however you draw it, so you could have drawn it up here, you could have drawn it down further down if you have room like that. It's totally up to you. But the x values need to match up, okay? So they're actually really easy. It's just sometimes hard to wrap our brains around it, especially since we're starting with the derivative graph. but it should be starting to make more sense now, especially since we're going to quiz on it, right? Okay. Number 2, which of the following functions is both continuous and differentiable? So they've got to be both continuous and differentiable, okay? So it does say that we get to use a graphing calculator here. So that's kind of nice. And that's only because normally we would have you guys graph these, but you guys are still getting familiar with having to graph these functions. So you're going to get used to what they look like pretty soon because you're going to see them a lot, and then you won't need to rely on your graphing calculator. But you do get to use your graphing calculator on this one. So pull them out and go to the y equals. And actually, let's set our window. Our window needs to be set from -4 to +4. So I'm going to go ahead and do that. I have it set standard. So I'm going to go up to the x min. Minimum's -4, maximum's +4. And then go to y equals. Okay. And we're going to type the first one in, and we're going to see if it's continuous and differentiable. So 1 divided by parentheses x squared minus 4. And close parentheses and graph it. My calculator's running a lot faster today. Well, we can see that it is not continuous because we have like a vertical asymptote here at -2 and a vertical asymptote here at +2. So it's not continuous. So that means it's not going to be differentiable on that interval. So we can say not continuous. And then draw a quick sketch of this. So it's just loop, loop, loop. Doesn't need to be perfect. No extravagant graphs. Okay, let's go to the next one. The next one is the square root. So second, and then the x squared button, and then x squared plus 4, and graph. There's no gaps, no breaks. It doesn't look like there's anything in there that doesn't look continuous, so it's continuous. And there's no corners, no cusps, no vertical tangents, so it's going to be differentiable. So it's continuous. And I'm just going to put diff for differentiable because I don't want to write that whole word out. I'm going to be a little bit lazy. And let's just draw a quick picture of our little, looks like a satellite dish to me. Okay, so B is a contender. I think it can be it. But we got to keep checking. So the next one is the absolute value of x squared minus 4. So I need to go back to the graphing calculator, clear that out. To get absolute value, you have to hit the math button, scooch it over to num, and then hit 1 for abs, not the abs on your stomach, but absolute value. And it's x squared minus 4, and graph. Batman. That's what it looks like to me, anyway. And that was from the old Batman, by the way, if you had no idea what I was singing. Anyways, so this is definitely, it's continuous, but because there's corners there at -2 and +2, the derivative is going to fail to exist there. So it's continuous. I'm just going to put cont for continuous, but not differentiable. Okay, and draw a quick little sketch of our Batman. Make it no, I'm just kidding. I know, I'm silly. Okay, next one. So y equals, clear out that one. I need second square root of x squared minus 4 this time, and graph. Looks like wings. So because the whole middle is missing, it looks like it's not continuous. There is definitely a big break right there. So it is not continuous, which automatically means it's not going to be differentiable. And let's just draw a quick sketch. Mine looks like angry eyebrows. And so obviously it's not none of the above. It was B. B was the only one of those that is true. Always check them all, because what if something tricked you and you looked at it weird, or you didn't understand what you were looking at or what you were looking for, make sure you check them all. That's a good habit of a good student that wants to do well on a quiz. So yeah, I want you guys to all have those good habits deeply embedded in your brains. Okay, number 3. This one can be tricky because, it's only tricky because you're still new at derivatives, and a lot of these definitions are brand spanking new to you guys, and it's hard to remember all these new things, okay? But you're going to get to that point where you will be confident because you're going to use these a lot. It's not just something that you learn and then you move on to the next topic like we've done in all these other classes. Like these things that you learned in chapter 2, we're still using them for chapter 3. We're just building on it. So it's going to be like this the whole year. All right, if f is a function such that the limit as x approaches 2 of f of x minus f of 2 over x minus 2 equals 1, which of the following must be true? And this is the part that is tricky. This should look familiar to you. It's actually using the form of finding the derivative, which we learned is also finding the instantaneous velocity. You guys remember that? When we're finding instantaneous velocity, we're finding the slope of the curve at that point in time, which is also the derivative. Another way that they would present this question is they might use the definition of a derivative. So the limit as h approaches 0 of f of x plus h minus f of x all over h. You might see it that way too. And that's using the definition of derivative. So you have to understand what that is telling you. So this is what it's telling us. It's saying the limit as x approaches 2 of f of x minus f of 2 over x minus 2 equals 1. So it's telling us that the derivative when x is 2 is going to equal 1, a slope of 1. Okay, so that is what this is telling us. Okay, so now we have to figure out which of these must be true. So let's look at letter A. F of x is continuous at x equals 1. Well, I don't know anything about x equals 1. I know what the limit as x approaches 2, so when we take the derivative of x when x is 2, the slope, the derivative will be 1, but I don't know anything about an x value of 1, so this is not true. I don't know. So if I don't know, then it's not true. All right, f of 2 equals 1. Well, I know that the derivative of 2 equals 1, but I don't know what the y value is when x is 2. This information didn't give me any of that. So since I don't know, it's not true. F prime of 2 equals 1. Yes, that is true. That is what this information gave us. F of 2 does not exist. Well, if the derivative exists when x is 2, then the point must exist on the original graph. If it didn't exist, then it wouldn't have a derivative. So this is not true. The limit as x approaches 2 of f of x does not exist. Well, if the limit did not exist, that means it wouldn't be continuous at x equals 2. And if it's not continuous at x equals 2, that means it wouldn't have a derivative. But it does have a derivative. So this is not true either. So the only one that was true was C. And you always need to check all of the options because you don't want to get tricked. Don't get tricked, guys. You're smarter than that. All right, number 4. The graph of f of x is shown below. There are horizontal asymptotes at y equals 4 and y equals -3. So we have a horizontal asymptote here and here, okay? Which of the following statements are true? Okay, so let's look at each of these. The limit as x approaches infinity, that means that we're going to the right along that number line on the x. So approaches infinity means we're going towards here. Says f of x equals 4. Well, as we're approaching infinity, we're hitting that a horizontal asymptote, and it is at 4, so this is true. Okay. The limit as x approaches -infinity, this means we're going to the left. So going this way on the x of f of x equals 0. Well, as we're approaching -infinity, 0, it would have stopped up here, but it's not. it went down to this horizontal asymptote, which we know is at -3. So this is not true. So this is false. If f prime of x is less than 0 for all, or sorry, f prime of x is less than 0, not if, for all x less than or equal to 0. So what is this saying? F prime of x, that means that we're saying the slopes are less than 0. Less than 0 means we're saying the slopes are negative for all x's less than or equal to 0. So less than or equal to 0 means that we're looking at the negative x values. So if I cover up the right side of the graph, let's look at the left side of the graph. And they're saying that the derivatives are all going to be negative here. Well, let's look at the tangent lines along this curve on that left-hand side. From left to right, are these little lines going to have positive slopes or negative slopes? Well, from left to right, these are all increasing lines, so they're all going to have positive slopes. None of these slopes are negative. None of these are going down from left to right. So this is not true. That's false. Okay, so the only one of these that is true is Roman numeral 1. So that would be A, 1 only. All right. Number 5. We started this one for warm-ups on Friday. You should have already written the piecewise function, but I'm going to go over that again with you guys so you can get a nice little refresher on it. Okay. So this is going to be very similar to the FRQ that you're going to get on the quiz. So this is a good FRQ practice, and you'll have another one on your review, I think. Yeah, you should. So it's a piecewise function. So try to look at the graph and figure out what the pieces are. I see a line that's increasing. I see what looks like a parabola, and then I see a horizontal line. So I see 3 pieces there. So let's look at it piece by piece by piece. So let's look at that first piece from left to right. Well, I know it's a line. Let's check out the slope. So from point to point, it looks like I'm going up 2 over 1. Is that happening the whole way through? Up 2 over 1? Up 2 over 1. Yeah. So it's a line, so we should be thinking y equals mx plus b, and I know that the mx part is a 2x. Okay. What's the b part? Where would this line cross the y-axis? So I know if I kept going, where would it cross? And it's not rocket science. You just have to keep going. Up 2 over 1, up 2 over 1. It would cross at 6. So plus 6. Okay, and what interval are we looking at? Well, this line is stopping at -2, and I see a solid point there. So it's all values at -2 and under. So less than -2. So x less than or equal to -2 is the interval. So there's that piece. Let's look at the next piece, the parabola. Now, when I write the equation of parabolas, I always use vertex form, translations moving left, right, up, or down. And we also have to look at amplitude. That's so easy to forget. I forget it all the time. Okay, so the parent function is always starting at 0, 0. This one has been shifted to the left 1 and up 1, 2, 3, 4. So to show it went left 1, it'll be x plus 1 squared, because it's parabola. And then it was up 4, so plus 4. Okay. Also, this parabola is facing down. So that means that there's going to be a negative in front of the parentheses, and it's not down 1 over 1, the slope or amplitude. It's going more than that. It's going down, it looks like 2 over 1. So that means that the number in front of the parentheses must be a -2. Negative because it's facing down, and 2 because that's what the slope is at the beginning there. Now, if you're having trouble remembering how to write the equation of a parabola from the graph, then reach out to me and we can do some practice problems on that. Okay, that's something from Math 2. We did use it in Math 3 for like a whole chapter on parabolas, second semester last year. All right, and then this last part, it's a horizontal line. Oh, almost forgot the interval. So the interval of the parabola is from -2 to 0. So since I'm already equaling the -2 up here, I have to use a less than symbol only, and then x, and then to the 0. And because that's a solid point up here and open down here, I can be less than or equal to the 0. All right, and then for the last piece, this horizontal line right here, I know that it's a horizontal line and it's starting at an x value of 0, so that means I can be at x's that are greater than, since I already used the or equal to up here, 0. And that y value, it would be y equals -2, so I'll just put -2 because that's the constant that it's at. Constantly -2. All right, so we should have already had this done in the warm-up, but in case you missed it or if you needed the explanation again, here you go. Okay, now let's answer each of these. It says identify a value of x for which the function f of x graphed above is continuous but not differentiable. Give a reason for your answer. So this is a free response question, so your responses need to be very thorough. Okay, so let's take a look at this. I know that I have a discontinuity here. So it is not continuous here. So that's not it. And I also know that the derivative won't exist here, but it needs to be continuous and not differentiable. So there is a spot right there. There's a corner. And I know that that is continuous there because there's no hole, gap, asymptote, nothing. But the slopes from the left and the right are very different. So the derivatives are not going to be in agreement there. So it doesn't exist there. Okay, so this is where it is continuous but not differentiable. So that x value is a -2. So this is how I would write that up. I would say if x equals -2, comma, then f of x is continuous. We have to state that it's continuous, but we can't just state that it's continuous. We have to state why we know it's continuous. So we say it's continuous since, or you could say because, since, first of all, we have to say that f of -2 is defined. We have to say that it is defined at that x value. And now we have to talk about the limits. To be continuous, that means the limit has to exist. So we can say the limit as x approaches -2 from the left of f of x equals the limit as x approaches -2 from the right of f of x. And that limit is going to exist where the point is defined. So it's going to equal f of -2. Okay, you could even put what f of -2 is. Instead of f of -2, you could put that the y value there is a 2. So the limit from the left and the right, they meet, and it's at +2 right there. Okay, so you could even put just what the y value is. All right, oh, that shouldn't be a period, that should be a comma. I stated that it was continuous, but now I have to state that it's not differentiable and then also why it's not differentiable. So if x equals -2, then f of x is continuous since f of -2 is defined and the limit exists and it's at -2, but it's not differentiable since, or you could put because, since the limit as x approaches -2 from the right of f prime of x. So now since we're talking about differentiability, we're talking about the slopes, the derivatives. Since the limit as we approach -2 from the left of f prime of x does not equal the limit as x approaches -2 from the right of f prime of x, and then period. Okay, so this is an example of a full write-up. So when I'm grading a question like this, these are the things I'm going to look for. I'm going to look for your stating where the point of continuity but non-differentiability is, and that's at x equals -2. I'm looking for you stating that it's continuous. Then I'm looking for you stating why it's continuous, and there's two parts here, where it's defined and then the limit statement. And then I'm also going to look for you stating, but it's not differentiable. And then also why it's not differentiable. And there's that limit statement there that shows why it's not. Okay, so I'm going to be looking for all those components. So like on a question like this, it would be worth 1, 2, 3, 4, 5, 6, 7, 8, 9. It would be worth 9 points just for this part. Okay, I'm going to look for those 9 things. Okay. All right, so I hope me breaking it down on how I would grade that helps you guys out so that you know what you need to put down. All right, letter C. It says use your equation to show that f of x is continuous at the x value you defined in part B. So we already stated why it's continuous, but now we need to show. We need to use our equation to show that it's continuous. So this is how you do that, and you've done this many times before. So since we're talking about the point where x equals -2, we're only looking at these first 2 pieces of the equation because that's where they have that common value of x at -2. Okay, so what we're going to do is we're going to set these 2 pieces of the equation equal, and we're going to plug in that -2, and we're going to see that it's going to be equal to the same value on the left and right of that equal sign. So 2, plug in the -2 for x, plus 6, we're going to show it equals -2 times -2 plus 1 quantity squared plus 4. Okay, so 2 and -2 multiplied, that's -4 plus 6. -2 plus 1 is -1. -1 squared is +1. -2 times +1 is -2. So -4 plus 6 is +2, and -2 plus 4 is +2. There we go. And your work showing that this works out is your explanation. So you don't have to do a write-up on that. Your work is doing it for you. All right, letter D. Use your equation, so we're going to use that equation again, to show that f of x is not differentiable at the value that you defined in part B, so at the x equals -2. So now we're going to show that it's not differentiable. So remember, differentiable means that we're talking about the derivatives, which are the slopes. So now we're going to show that the derivatives, when we set them equal, are not going to work. So let's find the derivatives of just those 2 pieces. So f prime of x equals, sorry you guys are hearing my kids fighting in the background. All right, so let's take the derivative of 2x plus 6. So the derivative of that is just a 2, so that's pretty easy. And that's for x less than or equal to -2. For the other one, we need to take a derivative of this, but that means we're going to need to multiply out the x plus 1 quantity squared. Later on, you're going to learn a shortcut on that, but right now, you don't know it. So x plus 1 quantity squared means that I have 2 quantity x plus 1s. We're just going to multiply that out. So that multiplies out to x squared plus 2x plus 1. And then when I multiply in the -2, it'll be -2x squared minus 4x minus 2 plus 4. Combine like terms here, then I'll have -2x squared minus 4x plus 2. All right, and then the derivative of that, well, we'd bring down that 2. -2 times 2 is -4, so I'd have a -4x. And then that exponent of 1, bring it down, I'd have a -4. The constant goes to 0. Okay, and this is at -2 less than x less than or equal to 0. Okay, all right, so now I have these 2. Hold on. Sorry about that. Okay, so I just had to pause it for a second because I had to yell at my kids because they were fighting. All right. So now we've taken the derivative, so now we can show that that f of x is not differentiable. Let's switch colors here. So we're going to set them equal like we did up above. Now here, there's nothing to plug the -2 in, so it's just going to be 2 equals, and we'll plug in -2 here for x, -4 times -2 minus 4. We can already tell that it's not going to equal. -4 times -2 is 8. And 2 is not going to equal 8 minus 4 is 4. Definitely not. Okay, so check mark, we just showed that they're not equal, so that it is not differentiable there at those slopes. And that's part D. So this is what your FRQ would look like. It's going to have a piecewise graph. You have to identify or write the piecewise function and the intervals. You're going to have to identify where it's continuous but not differentiable. And then you're not only going to state it, you're going to show it. Show where it's continuous and show how it's not differentiable. Number 6. Given the derivative, sketch the original. So another one of these, just like our, what was it? Number 1. Yeah, number 1, we did one like this. So this one's a little bit harder, but I think we'll have a better handle on this. So we're given the derivative, so that means that this is f prime of x. So I'm just going to label my graph like that because it helps me remember what I'm looking at, because sometimes my brain gets confused on what's happening, okay? All right, so I know that we're crossing through the x at -3, -1, and 3. So the slopes will be 0 there, okay? So that means that I'm going to have a flattened out line, you know, a tangent line that's horizontal at -3 on the x, and the slopes up here are positive, and then they go negative. So to go positive and then negative means I'm going up, flattening out, and then coming back down. So that means at 3, I'm going to have a downward facing parabola, so I could have that horizontal tangent line. So I'm going to have a maximum there. Then at 1, so these slopes are negative because we're still underneath the x-axis, but then we hit a flat line at -1, but the slopes are still negative, okay? So since I'm going down, decreasing, flattening out, decreasing, that means there must be a shelf that looks like this. There's my shelf. Going down, flattening out, going down. So it's got to be a shelf, okay? And then at 3, the slopes are still negative here, and then the slopes go positive, okay? So to go from negative to positive, this turn will be going down, flattening out, and then back up. So I'm going to have a minimum there at x equals 3, okay? So it's good to write it down and to point out those things to yourself so that when you graph it down below, you'll be fine. Notice how there's no y values written this time because those are guessing anyway, so who cares where we put them at? All we care about is where the max, shelf, and min are located at along the x. So at -3, I'm going to have a maximum. So I could put the maximum down here. I could put it up here. It doesn't matter. I'm going to put it up here. So let's see. I got to make sure that it flattens out and it comes back down. Okay. So I've got my horizontal tangent there at x equals -3. Okay. And then the slopes are still, they're negative. So they're still negative. Okay. And then it's going to flatten out and then it's going to be negative. So I got to do my shelf and I got to make sure that it flattens out at -1 and then it comes back down. So there's my shelf. And then now I need to have a minimum at a x value of +3. So I got to try to make this, oh, well, this part is hard because you got to make sure that it flattens out right here at 3. So probably needed more room so I could go more at an angle and then flatten out and then go back up. Okay, but these are the things that I'm going to be looking for. I'm going to be looking for that maximum at -3, that horizontal tangent there. I'm going to be looking for that shelf at -1 and that minimum for that horizontal tangent at +3. So I'm going to be looking for that. Your graph should look similar, but it may not be exactly like that. Okay, it could be up higher, it could be up lower because you're guessing on the y values. But the max and mins and the shelf should all be the same. And then number 7, which of the following functions is both continuous and differentiable? Okay, so this is where we're using the graphing calculator again. But this time it's on the interval from -2 to +2. So when I go to my window, I'm going to change that. -2 to +2. And go to y equals. and we'll start typing them in. So the first one is second square root of x squared plus 2, hit graph. And it looks like that dish. So this one is continuous and differentiable. Continuous and differentiable. And it looked like a really flat dish. Okay, so we know that this is an option. It works. Let's check the next one. 1 divided by, you need to use parentheses. I'm going to use double parentheses. X plus 2, x minus 2, close that parentheses, graph. This is just like on number 2, I think it was number 2, where it, where's number 2? I didn't draw it on my notes. It looked like this on the interval from -4 to 4, but on the interval from -2 to 2, we're only seeing this little part, the middle part there. So, since we're only seeing this part here from -2 to +2, it's continuous. There's no holes, gaps, or breaks. So I'm going to say that this one is an option also on that interval. And it just looks like this. All right, letter C, absolute value of x squared minus 2. Let's see if that changed based on our window being smaller. So I need absolute value, so math, abs, x squared minus 2, graph. Batman. Well, we've got corners, so nope. It's continuous, but not differentiable. Continuous, but not differentiable. That's because we got the Batman going on. And then letter D, y equals, clear it out. It's the square root of x squared minus 2. And it's our wings. So it is definitely not continuous. All right. So obviously it's not none of these. It's actually A and B this time. I think Mrs. Ardito didn't mean for this one to be an option, but on this interval it is. All right, and that's everything. So you'll see the review video next. Study, study, study for this quiz, you guys.